So in this video, we're going to graph square root functions. So we'll start off with just the basic square root of x, so we can see the shape and some of the defining characteristics before we apply transformations. So just like any function, if you really have no idea what the basic shape looks like, we can always pick some points and plug them in. So, if we, pick some x's, plug them in, and we'll get some specific y's that go with it. Now, we can pick whatever x's we want. Generally, we would like to stay close to the origin because small x's generally produce small y's. So, we could pick like 0, square root of 0 is 0. Now, if we went to the left, negative numbers, square root of a negative number is an undefined value, or if you're familiar, an imaginary number, which we can't graph on a real number line. So none of the negative x's will actually show up in the domain of the function, or any of these negative x's won't actually have any y values. But we can pick values to the right. We can pick like 1, square root of 1 is 1. If we picked 2, square root of 2 is not a whole number. So if we wanted to put it in our calculator and get some sort of decimal, we could. Same thing with 3. That's not any whole number. 4, square root of 4 is 2, right? So instead of just running down the list and picking like any number we want, since we know that the value of x we're going to select needs to be the square root, what I'm going to do in this video is to find main points to graph these things by selecting x's that are perfect squares. So 0 is a perfect square. Square root of 0 is 0. Square root of 1 is 1. Square root of 4 is 2. I'm not going to do 2 or 3, right? If I wanted to, the next perfect square value would be 9. Square root of 9 is 3. I'm going to select these values when I graph this thing. And then the trajectory of these points will follow through 2, 3, 5, 6, all the other values that I skipped over. So when I plot these points, 0, 0, 1, 1, like we said, square root of 4, 1, 2, 3, 4 is 2. Square root of 9, and it goes off the graph a little bit, but just so we plot it, is 3, somewhere about right here. And then we can see that there's going to be kind of this upward trajectory in this shape. So we can see that the basic shape of a square root function is going to be kind of this upward, trajectory. It's going to take larger x's to create bigger outputs, right? So it grows kind of quick at the beginning, but then it's going to take larger x's to grow faster. So like I said, when we move along, I'm going to use these, as many as we can fit on the graph, of course, to help build this basic shape as we move along. Okay? So if you're familiar with transformations, we know that if we know the basic square root function, any values that are added, subtracted, multiplied will either affect the x values of the function or the y values of the function. So since our basic function here, I'll just kind of jot it down, we were basically saying that f of x equals the square root. So, our y value is going to be established as the square root of x, right? So if this is my y, all of my y values will decrease by 4 when I plug the points in like we just did. Now, I don't want to plug points, so I'm not going to do that anymore. I'm going to anticipate certain values, right, perfect square values. I know that all of these points are going to be shifted down 4, and I know what the basic shape looks like, right? The basic shape starts at the origin, so I'm going to use the origin as like our starting point, and then this guy is going to move to a new location through these transformations, shifts, vertical shifts, horizontal shifts, and then we can build these main points from here. So since this one is just a shift down 4, I'm going to take that starting point, 0, 0, and move him down 4. So that basic shape, which is this guy, is still going to be built off of this. So instead of taking like all of the points and moving them, I'm just going to move this main point, this starting point for the square root function, and then I'm going to use my perfect squares as if this was the origin to build the rest of the shape. So from here, as if this was my origin, I'm going to, again, pick my perfect square values, right? If I pick an x value of 1, which would be 1 in the x direction, the square root of 1 is 1. If I pick 4, so 4 larger than this guy, 1, 2, 3, 4, square root of 4 is 2, 1, 2. Right? And if I wanted to, square root of 9, 9 further in this direction would be 3, but it goes off the graph. I'm just going to stop graphing things that go off. And then we have this shape again. Right? So we can do the transformation and apply that starting point, since a square root function like actually has like this starting point, because none of the values to the left will exist. So it starts here and then it continues on this way. So I'm just going to move that main point, and then I'm going to use my perfect square values, 1 and 4, or if I can fit more, like 9, square root of 1 is 1, square root of 4 is 2, square root of 9 is 3, to build that shape. So here we go. Let's do some more here. Right. So again, with my transformations, since this 2 is underneath the root with the x, when I pick an x and plug it in, this 2 is going to have an effect on the x's. So this is going to be a shift horizontally. If you remember, horizontal shifts are kind of backwards from the way we see it, is the way I like to think of it. So we would think in terms of x's, plus 2 would go this way, but since it's backwards, the plus 2 is going to move it to the left 2. So again, I'm going to take that starting point, that basic shape, move it to the left 2. So this square root graph is going to start here. Then I'm going to build my perfect square value. So from here, an x value 1 larger, square root of 1 is 1, right? 4 larger, 1, 2, 3, 4, square root of 4 is 2, right? 9 larger, 4, 5, 6, 7, 8, 9, since I can fit it on the graph. Square root of 9 is 3, and then there we go. We have this shape again. Right, so do the transformation, shift it to its new starting point, and then we can build the y values off of this thing. Right? Let's try it out. Okay, so we have a new value on the outside, right? So we'll take care of that as we move along. We know that a value inside with the x is going to be a horizontal shift. This added or subtracted value to the square root will be a vertical shift. So this guy is going to be moved right 3, right, because it's backwards from the way we see it, right 3, and then a plus will move it up 1. Okay? Now, if we looked at just the basic function with a negative in the front, if I produce a y value, square root from the square root, because I would do the root first, right, picking an x, all of these y values would become negative. So just like normal transformations, a negative as a multiple to the root is going to be a reflection over the x-axis, because if all of my x values are positive, for instance, in this case, now multiplying by a negative will make them all negative and put them below the x-axis. So the function will reflect over the x-axis before it shifts, right? I mean, technically it would shift to the right first, because in order of operations we would do what's inside, then reflect it, and then shift it up. So basically this is going to be facing down. So I'm going to do the transformations first so that I can look back at this basic shape with this like a value, I'll call it, right? This value that's being multiplied. So again, I'm going to take this and move it to the right 3, up 1. Now I'm dealing with this function because I've moved its shifted location to its spot, and I can deal with kind of how this negative affects the shape. So I'm still going to plug in perfect square values. If I pick a x value 1 greater, square root of 1 is 1, but then 1 times negative 1 makes it a negative 1. Right? If I pick an x value 4 greater, 1, 2, 3, 4, I know that the square root of 4 is 2, and then 2 times a negative 1, or the opposite 2, is negative 2. So I can deal with my shift and then deal with how the negative will affect kind of where it's at from here if I want to do it that way. So this guy was reflected down. He's still going to have that basic trajectory, just moving downwards. Right? Let's try again. Okay, so I'm going to do this pretty much the same thing, right? In terms of the transformations, if I move him left, because I do what's inside the root, then I apply this multiplication, right? This guy is, the height of it is going to be adjusted, right? This will be a compression, because whatever my y value is here will be half of that amount, and then shifted down. So if all of my y's are getting shifted down, I can take care of the transformations first and then just apply this to where it should have started, right? So if I go left 1, down 2, this is going to be its new starting point. It's going to have this kind of basic trajectory that we know of, but all of the trajected points are going to be half the height that it was. So if I were to put in a 1, square root of 1 is 1, but then 1/2 of 1, because remember, I'm looking at this now, right? Square root of 1 is 1, and then half of 1 is a half, so, instead of going up 1, I'm going to go up, a half, which is, somewhere right there. If I go out 4, square root of 4 is 2, but then 1/2 of 2 is 1. So instead of going up 2, I'm going to go up half of that. Right? If I went out 9, the square root of 9 is 3, but half of 3 is 3/2, or 1 1/2. So we still have this kind of upward trajectory, but it's not increasing as quickly because I'm halving that height there. Right? All right, let's try one more. So again, I know my transformations are going to be affecting this in different ways, right? This is going to be a shift to the right 1. This is going to be a shift up 5, right? Even though order of operations says I would shift it right, then do A, and then up, since it anchors at the origin, the reflection is just going to make it face down. I don't have to compensate for where it's at. So I'm going to go right 1, up 5, 1, 2, 3, 4, 5. Right? And then again, I can just deal with how my basic root gets affected by this -3. So again, I'm going to pick perfect roots. If I pick 1, square root of 1 is 1. 1 times -3 is -3 from here. So 1, 2, 3. Right? If I pick 4, 1, 2, 3, 4, from here, 1, 2, 3, 4, square root of 4 is 2. 2 times -3 is -6. So 1, 2, 3, 4, 5, 6. Right. If I pick 9, it's going to go off the graph, so I won't pick that. It's going to start here. I can see that it increases faster, but then starts to slow down as it's coming out over here. We can kind of anticipate that basic trajectory. All right? Because remember, just kind of covering it up here, this shape, the height is increased by 3. Right? So we can kind of see that if I started at 1 and then said square root of 1 is 1, this height is going to be 3 times that which it was here. If I went out to 4, square root of 4 is 2, so this height is 3 times of what it was there. So when we look at this thing, we should be able to kind of anticipate what the general shape is going to be. That 3 is going to extend this out further down this way than that basic shape, even though it's reflected. So instead of it going up, it's coming down. The 3 is going to increase that height, so it's going to make it a lot taller. Just like this half shortened that height, it made it a lot smaller than what it would have been. All right, so a lot of times you can look at these and kind of in your mind's eye see what's supposed to happen. That way when you get this answer, when you're done, you know it's looking like what you anticipated. All right?